Turn that on and turn this. What is this? Why is it not going high? Perhaps up, down, will go up high. There we are. All right, good. So, don't need this for now. All right, so this is the second class, and I got a few minutes before. Oh, it's actually 10 after, according to my computer. I guess that clock is wrong. All right, well, then we can just start off here. So there is. So we've been through the first chapter. We're going to do the second chapter today. Yes, let me see if I can get this junk out of here. I have to mute everyone. Someone told me that will help prevent that. Well, it doesn't seem to. All right. Anyway, all right. So you should have done the first couple of quizzes. If you didn't, I'm not going to take points off for being late at this point, but you should. And I won't take too long to do the lecture today, maybe about an hour, and I'll go to the lab afterwards to help anybody that wants help. And all right. And one thing I've noticed this semester is a great many students are totally unable to use VMware on Windows. If you're trying, it would be a whole lot better to use a Mac or use a cloud machine. VMware seems to be pretty much broken on many Windows machines. Can you close that thing behind you? It's going to be shining in my eyes and making life difficult. Oh, good. Anyway, so yeah, it looks like this thing is not going to stop popping up. If some student becomes an expert in Zoom and they find out how to make this thing quit popping up on the screen, I'd appreciate the tip. This thing with the videos keeps popping up every few seconds. And someone told me muting the students would stop that, but it doesn't. There must be some way to turn it off, but I haven't figured it out yet. Anyway, so let's, however, there's always something. So, all right, so let's talk about DNS security here. In the early days of the internet only had a small number of computers, 4 servers is how it started, and so they had manual addresses, and everyone just typed in the addresses. Then they started having this file in a host.txt file that they would ship a floppy disk around or put on an FTP share or something. And finally, the internet grew fast enough that they needed some kind of database, so they developed one of the earliest distributed databases. And that was 1983. And the plan here is the DNS data should be distributed across many servers so that even as parts of the network become unavailable, people can still look up domain names. And you have this hierarchical organization of the domain names, which is very nice. The DNS is hierarchical and the zip code system is hierarchical, and they're efficient for that reason. So here's how it looks. You have a fully qualified domain name like hills.ccsf.edu. On the right is the top level domain, edu, and there originally were only 7 top level domains approved. Now there are more, but still almost everybody still uses the original 7. Then is the name of the company here, ccsf.edu, and then the specific host at the company location, hills.ccsf.edu. That's what's called a fully qualified domain name. And this is hierarchical. The root of the domain is a 13 server clusters with 13 independent names. And the only thing the root stores is the location of the top level domain DNS server. So it stores where .com is and where .net is. So you ask the root where .com is, then you get .com. You ask .com where it would be edu, but anyway, or like yahoo.com is, and that sends you to the authoritative domain controller for that company, which can then tell you where a specific device like www.yahoo.com is. That's how it works. And so every server is, some servers are merely recursive, like your router. You plug in at home with the router, and you get all your DNS resolution from the router, but the router doesn't know anything. All it's doing is asking your ISP. So it is a recursive resolver, which means you ask it a question, it just asks somebody else and tells you the answer, but it doesn't really know anything itself. All it does is it knows who to ask. But you can also be an authoritative resolver, and you'll set these up in the later projects, where if you are really the primary resolver for a domain, then there is some region where you are authoritative, like City College has an authoritative resolver, and we have various servers here, and we have our own authoritative resolver. So if we add a new server or change something about one of these servers, we change the data on the authoritative resolver, and all the rest of the internet will eventually update from that. So if you want to find out that a server does not exist, you have to go to the authoritative resolver. If you don't, you have no way to tell whether that server really doesn't exist or whether it's just that the local cache of the other machines doesn't happen to have that record. The only way to get a negative answer is to go to the authoritative resolver, and that's called a zone. A zone is the region your resolver has the data about. So you can have domain delegation. We could even sub-delegate where you have different campuses having their own DNS zone, and each one of them is authoritative or their limited zone. You can break it up any way you like. All right, so you have a DNS client is a machine that wants to resolve an alphabetical name like yahoo.com into an IP address, and it has to get service from somebody. This is typically your browser or your operating system. Yeah?
I had a question on one slide there. Would you mind giving a moment to talk about www in relation to these web addresses as opposed to like HTTPS?
Well, www is just the name of a server, and I have no idea why people started putting it in front of servers. I guess it must come from a time when, before the World Wide Web, and all there was email and FTP, and maybe there was some time when people, I don't know why they did. It became a tradition. An enormous number of students believe they have to put www before every URL. I don't know why that started. Most people don't use it anymore, like Microsoft.com and Google.com, but if you put it in your browser, we'll try it with and without. It's pretty much a useless appendix, I think, at this point. It may have made some sense back in the 80s. But anyway, you can have anything you want there, up to 64 letters, and it's a way you can have as many devices as you want.
Okay, so www isn't really required for anything or any particular service or function to work.
No,
And
in fact, this name is just an ornament. You can have any name. You can have fred.cc.edu, and that could be an email server or an FTP server, anything. So this name is not used to define the function of the server at all. It's just a name by convention. There are certain common names people use, and there are some people that recommend choosing weird names to make it harder for people to find your servers who don't belong there. But the standard is like FTP, MX for mail records, NS for name servers, and www for web servers. But there's no real reason. Your browser will go to anything. You can open an FTP. So it's just a name. It means nothing more than one of our names. It's a good question. Yeah, because I see an enormous number of people think you have to have a www in front of a URL, but you don't. Now, the HTTP or the HTTPS is important. That is not an issue of DNS. That is an issue of what service you connect to at the other end. That's called the protocol. So modern browsers tend to hide it. But here you see I'm HTTPS. That means my server is going to serve encrypted HTTP. If I put HTTP there, it'll look for port 80 unencrypted HTTP. If I put FTP, it'll go to port 21 and look for FTP. You can have SMB, you can have TELF, mail to for email. And on phones, there are a lot of goofy ones like TELF for telephone numbers to make phone calls and stuff. Those handlers up there, that's what the first few letters determine. They actually determine which service you're going to try to get from that server once you get there. This is essentially the layer 4 port number.
Cool, thank you.
Yeah, good. I'm glad you brought it up because people often get these things confused. All right, so the client is your browser. The server is something that can provide DNS service, and a DNS resolver is the software that accepts a query, finds the answer, and gives you an answer. If you're only using one server and it's not recursive, then the server and the resolver are the same. You ask one server and you get an answer from that one server. But most of the time, we are using recursive resolvers, which will go find the answer and tell us whether they had, and we don't know or care whether they had the answer locally or they had to go somewhere and get it. We just want the answer. So I say authoritative servers are the ones that actually have the master copy of the information about one domain. And so if you get to the authoritative server, you get an answer, and that is the highest degree of accuracy. In order to make it faster, all the DNS servers on the internet pretty much cache records. So if somebody goes to yahoo.com and somebody else goes to yahoo.com a minute later, they don't bother asking anybody else. They remember from the previous query for some period of time that they've already been there. This means people get faster service. It means that the people that own authoritative name servers do not have to handle as much traffic. But the cost is, it means that the data you're getting is out of date. So if you change the location of a server, it takes time for that information to percolate. This is a fundamental problem with DNS. DNS has no push capability. It is a pull-only system. So if I change a record, I have no way to inform people the record has changed. All I can do is wait for them to ask and discover that it has changed. So that's an issue. All right. So that's the time to live is specified by the start of authority. You put a time to live on the record, and that tells it, other servers, how long they should cache it. All right.
Question.
Yeah.
Sometimes time to live is number of hops versus seconds. Do you understand?
Time to live at layer 3, layer 3 with IP is number of hops. This is time. This is seconds only.
It depends on which layer you are.
Well, yeah, yes, unfortunately, yes. And by the way, the time to live at layer 3 in IP is never really seconds. In fact, they removed that entirely in IP version 6 and changed it to the hop count. I don't know whoever thought, the idea is it should count the number of hops, the number of times a package has been regenerated as it passed through a router to move to a different network, that's a hop, or the number of seconds it has waited for that service. And no router ever has a queue so long that a packet waits a whole second. And I don't think they ever have. So that calling it time to live has always been just a misnomer. It's really hop count.
Was it milliseconds?
No, it's seconds.
Okay.
And therefore, and not only does that never happen, but people, I think, checked the software, and nobody ever wrote software that actually counts the seconds to do it. It is just, whoever designed it gave it a foolish name and a foolish rule, which everybody just ignored, which is, by the way, introduces another fundamental issue. The internet is not regulated in various ways. As we're all finding now, it's not regulated for political content. That's the current thing. We all know it's not very well regulated for crime and malware and pornography and spam and all that stuff. But the other thing about it, it's not even technically regulated. There is no authority. You have, if you build a browser or a new computer, you don't need to get permission from anybody to connect it to the internet. So you don't have to do it right. You can make your device where it sends out the wrong kind of traffic, and all that will happen is some people, you won't reach them. So this means that all the equipment running the internet does not really obey the rules. It just does whatever some manufacturer felt like works good enough, and off they go. Microsoft used to be the king of this. Until about 8 years ago, Microsoft was famous for completely ignoring the rules of the internet and just doing whatever they wanted. So everybody would have to make a web page, and then you'd have to modify your web page so it would look good in Internet Explorer, which totally didn't obey the rules. Because Microsoft said the RFCs are the official rules of the internet. They're made by standards bodies that are basically academics, the IEEE and other companies. Academics get together and have meetings and decide what they think HTML should be in TCP and IP. And then companies have those documents they can study, but they often don't, especially Microsoft didn't, and they just don't bother to obey the rules. They just make something that they think is good. And since they had one time 95% of the whole desktop market, they said, we're the elephant in the room. Whatever we do, that is the rule. These guys can talk until they're blue in the face with their stupid rules, but whatever we do, that's it. And Microsoft, as they declined in popularity, and after they had an antitrust lawsuit for doing this along with many other abuses, they really started obeying the rules much better as far as their browser. But anyway, that's the thing to know, and it leads to bizarre things. When I upgraded from Windows XP to Windows Vista, I lost my internet connection. And Kirk, one of the longtime students around here, he told me, your router is not compatible with Vista. And I said, that's impossible. How does my router even know what OS is there? And it's true. Vista changed the packet so your router couldn't see it anymore, which means that either XP or Vista or both of them were not really obeying the rules. And I had another one of these. A friend of mine bought a Bluetooth speaker, and it wouldn't work. He had an Android phone and an iPhone. And he said, when I went in the store, they said I had to know whether it was an Android phone or an iPhone to buy a Bluetooth speaker. And I said, no, Bluetooth is a standard. It interoperates, and that is not true. Either Apple or Google or both do not obey the standard, and you cannot use the same speaker for both of those phones. At least you couldn't a few years ago. And I didn't believe it until I saw it.
The Apple only speakers?
They typically say they're good for both, but they don't really work on both, which means they're not really speaking the standard. And this is the way it is. Anyway, it's a thing to know. There is a standard, which is a goal to aspire to, and manufacturers don't really 100% meet the standard. So,
right now, the standard Android and standard Apple.
Yeah. Yes. Well, that might be it. Maybe they finally diverged. Anyway.
It sounds like Apple's not.
I think probably they both don't really exactly meet the standard. Anyway, so we talked about this recursive queries, or you ask a resolver and it will ask somebody else and bring you the answer. An iterative query is the alternative, where you ask one server And if it doesn't know the answer, it will tell you, I couldn't find the answer, go ask somebody else. It's now your responsibility to go ask someone else. These are just two ways to do it. And in principle, they can both work.
Yeah. Question on the authoritative servers. So
yeah.
You mentioned that the CCSF has its own authoritative server
yeah.
for this domain.
Mm-hmm.
For this, it wasn't domain. What was it for that area?
A domain, and they call it a zone. We could be split into zones, but our zone is equal to the domain, which is true of most small companies.
So outside of the zone, is that particular server recognized as an authoritative server?
No.
Okay. So there's
Each
no
authoritative,
top-down, like
each
you can't
authoritative
get a certificate for your server to be recognized elsewhere as an authoritative DNS.
Well, here you raise a lot of thorny problems. And one, it would be nice to imagine that there's a certificate. The insecurity of DNS is mind-boggling. Not only is there no regulating who joins or whether they obey the rules, there is no encryption or password authentication anywhere. So there's no certificate of what zone you're authoritative over. What happens is you publish an SOA record in DNS that tells it where the authoritative server is, and that's it. So you could, I think, publish a false SOA record and trick people into going to the wrong server and regarding it as authoritative. I think there's nothing to prevent that. I haven't heard of that particular attack, but we'll see a lot of others. And there is a cure for all this called DNS Sec, where you actually have signatures. So you actually know who's talking and whether they're allowed to say what they're saying, but that is in its infancy and of no use yet.
And so when I do an NS lookup and it spits back authoritative or non-authoritative result, right? Where is it getting that from?
Well, let me do it here. This is a very apt. Let's do a demonstration here. And in fact, it's good because City College has changed our record a few times. Let me just have a new window because that's full of horrible stuff from a CTF. All right, so if I do dig, ccsf.edu, if I don't tell it what server to ask or what question to ask, it will look for the A record of the unqualified domain, and that is going to be our primary web server, 147.144.1.2.12. And since I didn't tell it what to ask, it'll just ask whatever my default resolver is. And this is whatever the default that comes in from City College Wireless is. Now, if I wish to control who I'm asking, I could put an @ here. And I could ask a public server like 9999 about it. And it'll give me the same answer. But notice the time changed. This was 559,000 seconds. This one is 604,800 seconds. And I don't know what happened here. All right. And if I do it again, I'm getting a different answer from the same server, which means it's really a server cluster. So, all right. Anyway, now, if I want to know the authoritative server, I will ask, I don't care who I ask, but I'm going to ask who the start of authority is. Okay. And now, the start of authority is this, which is actually very strange because even last night I got a different answer. Last night I got ns3.ccsf.edu, which is equal to your project. So that's kind of disturbing. We've been changing something about our DNS here, and somehow we seem to be flapping back and forth between two authoritative servers, which is not right. And we have before had problems with our DNS where it keeps going wrong and back, and it looks like we managed to do it again. In fact, let's try asking a few different people this question. In a perfect world, everybody would have the same answer for that question. But see, here they don't. 8.8.8.8 thinks it's NS3, and the default one from City College thinks it's something. Oh, on campus, they have a different start of authority. This is, our DNS is split in a very strange way, for probably no really good reason. They have a different set of DNS records for on-campus traffic and off-campus traffic. And this leads to a lot of weird problems. Anyway, so let's stick to the external stuff. The external ones all agree that it's ns3.ccsf.edu. So I got this information from Google, and therefore it is not authoritative. And if I ask Google, but if I ask the start of authority server to tell me about this, which is this, instead, I should get an authoritative answer. And
this tool I'm not seeing, is it throwing up a code there that letting you know if it's getting an authoritative or non-authoritative?
There will be, it doesn't tell you if it's not authoritative. Yeah, I think it might be authority 0. Here, okay, couldn't reach it. Let's, oh, that's because I can't reach this one from on campus. All right, I have to use the other one. Okay. Let's, I could do something like that or a VPN. Let's try this one, which is supposedly the authoritative one on campus, and see if that will give me an authoritative answer. Yes, all right, so this gave me an answer, and it should have told me that it was authoritative, but it didn't seem to, so I'm thinking there's some kind of problem with our, let's try the A record and see if it does any better. I'm going to go to somebody else. Let's get away from City College. I think our City College system is pretty messed up. Let's go to like Yahoo. Maybe Yahoo did it right. Okay, here's Yahoo. They got a lot of servers, but they're only going to have one SOA. Okay, so there's the start of authority for Yahoo, ns1.yahoo.com, which is pretty logical. It may be a cluster, but it's still, anything with that name is interpreted as authoritative. So now if I go there and I ask where yahoo.com is, I get information and it should tell me that it's authoritative. And it should have, there it is, that's the flag, AA, authoritative answer. This tells you how many authority records came to tell you who told me this. But this is the thing, the AA means you've reached an authoritative server. And in Windows, you use NS Lookup in one of the projects and it's loft dot something. But this means I actually reached an authoritative server, so this is the most reliable answer I can get. Using this extremely messed up system of UDP unencrypted traffic, which could be modified by anybody. But unless the traffic has been spoofed, I've reached an authoritative server. And if you turn on DNS encryption options, you can even have a higher degree of confidence that you're actually talking to the right server, but all those protocols are in their infancy. Anyway, so that's the game there. Sure, I'm glad you asked it. We're trying to make this as clear as possible. So now you can have DNS forwarders. These will just forward traffic for DNS resolvers to go somewhere else, just for load balancing, and they can cache records. It's another form of a DNS server, a caching server. DNS resolvers take this data and forward it, and a stub resolver is one that connects to only one recursive server. This is what your router at home is. You buy a Linksys router, you put it in, all your computers at home go to it, and all that router does is ask one other server, your ISP's DNS server. So it's really doing very little. It's just forwarding every question to the ISP and then handing the answer out to your local machine. But that's really all it's doing with the internet too. It's getting all the internet from that one connection to the ISP and then just serving out among the machines. All right, that's called the stub resolver, where the resolver really isn't doing much. So you got a local DNS server, which is a number you put on your computer, which tells it what to use. So down here, if you ipconfig/all, you'll see your DNS servers. And you're supposed to have two, but you might not. Anyway, this one here is 192.168.119.2. That's the DNS resolver that will be used by this computer. It will ask that IP address to find things, and that is usually a stub resolver going off to an ISP. But you could choose to use a cloud service, and this would have some considerable benefits. There are a few numbers you should know for real-world work. I'll just write them up here in case you don't. If you need a DNS resolution and your local DNS resolver is not working, which happens fairly commonly, you should know some public ones. Google is 8888. A new one is Quad 9 from some other company. Another one is 208, 67, 222, 222. Now that is OpenDNS. And that one has an interesting property. Not only will it resolve domain names, it will also filter out malware. If you try to go to a site that is known malicious, they will not resolve it correctly. They will tell you a lie and send you to a page that says, no, don't go here. This is a bad site. And they can also fix broken domains. They did this. There's we'll talk about these attacks later, but about 6 years ago, the Syrian Electronic Army, which at that time was one 17-year-old in Syria, loyal to Assad, hacked the New York Times and many other websites, but the biggest one he got was the New York Times. And what he did was he contacted the New York Times hosting provider, their DNS name, not their hosting provider, but their DNS authority that they registered with, and convinced them that he was representing them and he was moving to a new address. So he changed the DNS record for the New York Times address to go to the wrong site. So the entire New York Times vanished from the web. And OpenDNS not only protects you from malware, but they have a thing called the Umbrella Project, and they've had a lot of conferences and they've been talking about it. They are constantly figuring out the criminals on the internet, and they're doing threat analysis of them, so they know what's happening. And so they knew exactly that this had happened, and it took the New York Times something like a day to resolve it. So the owner of OpenDNS called the owner of the New York Times and said, how about I keep sending people to the right website who are my customers, because I can send them the right address. Well, even though it's going to take you a day to get the right address on official channels. So that's what he did. So in that case, OpenDNS customers continued to see the New York Times when nobody else could, because he was able to correct the defects in the system. Anyway, after that, I contacted a whole bunch of companies and warned them that their domain name was not locked at the registrar, which is an optional service. And it was funny, they all ignored me or said, they said, this isn't important. And then like 3 years later, some of them paid me like hundreds of dollars for bug bounty, saying, that was actually a good tip now that we finally understand what you were talking about. Anyway, I don't get many bug bounties because I don't usually do the fashionable thing. Frequently, I'm telling people something and I say, this is weird. What are you talking about? Get out of here. All I wanted to hear was that you can use a cookie and get into someone else's Facebook account. I don't know what you're talking about, DNS. Anyway, so here's typical. This is what you're typically doing when you're surfing the web. You type in something like ccsf.edu, your resolver sends it to your DNS resolver, your stub resolver, and your operating system sends it to a DNS resolver, which doesn't know the answer, and it asks somebody. It asks one or more of these other servers until it figures it out and then gives you the answer. All right, so DNS replication is happening across the internet. Now the simplest form of copying DNS data comes from caching. Each one of these servers, when asked a question it doesn't know, will find the answer and then cache it for a period of time. That's one form of copying, but you might want to put up another whole server to handle the load. In that case, you need to copy the entire zone file from one computer to another. And that's called zone transfer, and that's what happens here. Your master server copies all the data over to the slave server, and that is sent over the same network with the same kind of protocols. And in the original system, DNS resolutions were done with UDP 53, and zone transfers were done with TCP 53. So it was a fairly common security strategy to block TCP 53 at the edge of your company to stop unauthorized zone transfers. You can't do that anymore because DNS answers got too big, and many people now move normal DNS queries over TCP. But that was the old system. We made, if you remember from your Net Plus earlier classes, the well-known ports, the first 1024 ports, are always assigning both UDP and TCP to the same service. UDP, UCP, and TCP 25 go to SMTP, UDP and TCP 80 go to HTTP, even though usually you only use one of those, UDP or TCP, but DNS uses them both, and it uses them for quite a few different purposes. But most of the traffic is UDP 53 for normal name resolution. All right, so I mentioned the root servers already. The root servers up there, and you can see the root servers if you just do dig. If you do dig and you tell it absolutely nothing else, it goes to the root servers, and all the root servers, and here's a list of the root servers, and this is all it has. It finds the root servers. And they have a very simple naming system. These are all each server clusters, and they have, the only thing they have is the addresses for top-level domains. But that's the heart of the system. It is a hierarchical system. All right, so that's the game there. So if you were to reboot your DNS server and it knows absolutely nothing and turn it on, the first thing it has to do is ask the root, where is .com? Then it can ask .com, where is yahoo.com, and after a while it knows things. This is like when you boot up a switch at layer 2, your switch has to be a hub at first because it doesn't know what's plugged in. It's only after it receives some traffic that it can figure out what's plugged into the ports, and it's only after it receives some STP signals from other switches that it can learn which wires to deactivate to avoid making loops at layer 2. This is networking devices have to power up and have their processor running, and then they have to have a certain amount of network traffic to get them started. And DNS is the same in that regard. There are hundreds of servers in the root zone. They are treated with 13 domain names, which is not just 13 servers, it's 13 distributed clusters. And that's how it all starts. So let's try the Kahoots. I've got them.
What's the Wi-Fi?
There should be a guest network, hopefully. Yeah, use the guest, that's the best one. The other one, you have to sign up somewhere for it, and they keep changing it.
Cool.
But I guess you're still up, and that gives you less harassment. Yeah. So here, and favorites. There. Good. All right. Good. So go to Kahoot.it. What's that? Oh, okay, well, you can do it on your phone. Yeah.
Oh, yeah. That's a good question.
Yeah.
So I think I have to
If you have a Kahoot app, or you can just go to Kahoot.it in the browser. There is also a Kahoot app. I have not used it, but I see an ad there for it, so I guess it exists.
Yeah, I think we're gonna need it, but I don't know if I
People are doing pretty good stuff with the ASCII art. All right. While that's happening, I'm going to bring up my score sheet so I have a place to put it. All right.
many more people in that game.
It's hard to say. I got maybe 12 or 15 in the room and 11 online. Not everybody Kahoots. There are Kahoot abstainers, just like people who don't vote. You know, there's a Kahoot turnout that appears to be about 50% this semester, which is not normal, but I don't know. Anyway, all right. Is anybody still joining?
I got it on the phone.
You're in? Okay. I'll give it another 5 seconds and then we'll start. Not a hacker. This person has to leave. All right. Okay. So, okay, you add a new server to a domain. Where should you put the DNS record? All right, at the start of authority, that's where you put it, and all the other servers will eventually copy it from that server. All right. What process copies all the records from one server to another? All right, that's a zone transfer. Everything in the zone goes to another, and the zone is the area of data that your server covers. All right. And what device stores all the DNS records for a zone? All right, that's what I thought. It's just a server. Resolver is something else. I'm not sure I know exactly the difference. Let me see if I can figure it out. I don't necessarily. What exactly is okay? Resolver. Okay, we're like a stub resolver. Okay, resolver doesn't necessarily have any data in it. It can just be doing recursive queries. It doesn't store any records to be a resolver. Okay, fair enough. Good. All right. Oh, that's pretty good. Look at the winner. Anyway, so which of these is an FQDN? All right, that's it. That's one where you have the name of a server, the name of a domain, and then a top-level domain. That's fully qualified. Yeah, yeah, that's it. All right. And which of these is a TLD? All right, that's info, the thing at the end. By the way, even they brought out all these new domains to make more domains available, and they discovered that customers will not go to anything other than .com. Customers have a strong belief that anything weird like .info is just an evil, malicious domain, and this belief is grounded in reality. 90% of them are just evil, malicious domains. So anyway, that's a good clean. I got an info because it was new, and I thought that would be cool, and it was cheaper. And now info kind of came and went, because if you get your company.info, the customers won't use it because they know that's probably the fake one serving up malware.
Well, wasn't that too globally panned moved by ICANN? It's just like a cash grab. They're just creating these things to buy because they could.
Yeah, well, people did in fact argue about it. ICANN has had a lot of criticism for their handling of domain names, and in particular, you can have a new domain name, but you have to pay them $185,000 for the privilege. And there are a few of them out there like .horse. I could get samsclass.horse pretty cheap. Anyway, I haven't done it, but I could.
But if you wanted a new .word,
If you want to make a new word, but then you own it, you can sell it to people. You could. You could make .sam and sell it to people. But I wanted to make .cat, but cat is actually the nation code for Catalan in Spain, and they're tired of everyone trying to put up cat jokes, which is what I was going to do. And they absolutely won't let you put up a page if it's not about Catalonia.
Oh.
They're really mad if you want to put up a cartoon of a cat, which is in fact what I was going to do. What's that? No, it isn't. Yes, apparently not.
Okay.
And they're very proud of it. Anyway, so
Very proud of the country.
yes. All right, so what system performed name resolution before DNS? All right, the host's file, just a list of addresses. All right, so I've got Face, who will have to tell me who they are, and Andrew, that looks like a real name, and Wayne looks like a real name. So the Facey person will have to give me their name at some point if they want credit. And I'm going to save this as Tim. All right, so let's take a look here. And all right. I think we can carry on a bit. We may take a break before finishing this. All right, so here's the types of records you find in DNS. Each one of these things is called a resource record. You've already seen a few of them, and A is the most common query. You want the IP version 4 address of a server so you can connect it. That's normally what you want. Quad A is growing in popularity. That's the IP version 6 address. Now something like 10 or 20% of all the traffic in America is IP version 6. Most people don't know or care, but it is. And then it's used, what's that? What's that?
It needs to be both to make the switch over to the more numbers.
Well, yeah, that's some people are supporting both. A lot of people are still on IP version 4. Almost nobody is IPv6 only yet, but they're both out there. So NX is the email servers to which send mail, pointer, PTR records, or host names for reverse lookups, which you can start from the domain, from the IP address and look up the domain name. And then NS is the name of the name server, either start of authority or other names. And CNAME is a canonical name. You can put a name up which resolves to another name, just a shortcut. And here's the start of authority, gives you information about the root zone handling the record. And text is for general information. You can put up a variety of text records, and there are several of them which you must put up if you want to send or receive email, because as an anti-spam measure, when email servers receive email, they then query the server to find out if it is the expected server to be sending mail from there, and if it's not, they throw it away. Because the spammers are sending so much mail with false from addresses, there are 2 or 3 competing systems to block that. And this has led to a lot of problems, and I know one problem has been this semester at this college, we're losing a lot of email because various servers do not like our current DNS setup, which is why they're changing it, trying to fix it. For example, Amazon will not give any of you free Amazon Cloud time because they do not recognize us as a college email address. They say our EDU mail servers are not set up correctly for Amazon to accept them. Google accepts them, so my homework is now on the Google Cloud and not on the Amazon Cloud yet, because you can get free Google Cloud time, but you don't get free Amazon Cloud time. We are trying to negotiate with them to be included. But we are set up in some way that there are automatic systems think we're a spammer pretending to be a college, not a real college. So you got other ones here: naming authority, pointer, service records. Sender policy framework is one of those email anti-spam measures. And then there are the ones for DNSSEC that I mentioned, which is the one that adds signature and encryption to this stuff, so that you actually have some authentication on DNS. And these records are used there, and we'll talk more about them later. The main thing to know about them right away is that those records are used only by DNSSEC, which is almost useless because nobody enforces it much. And they're very big, so they greatly increase the size of the responses, leading to a lot of problems.
And what is RR?
RR is resource record. All these are called resource records. Yeah.
Can you dig for each one of these?
Yes, you can. Yes, absolutely. And so let's try some of that. If I want to dig for, say, SOA at yahoo.com, I can do that. Now, if I go to a highly cool technical group that obeys all the rules, like the people that write these rules, IETF, Internet Engineering Task Force.org, I will get an A record. And if you want to see if any advanced stuff is working, these guys will, of course, have it. Like they're going to have IP version 6. So they have a server at this address. And you can tell they're pretty awesome because their server starts with 4. They're one of the earliest entries in the whole internet. And here's their IP version 6 address. So they got that. They probably have some of those signatures too. Let's see if we have RR-SIG records. And we do. We got a bunch of RR-SIG records. And like I say, these things are big. This long cryptographic junk is like a HTTPS certificate. It proves that they're really them if you go through a system of queries to verify it. It is actually in base 32, which is really messed up. But if you want really messed up, go to Bitcoin. Bitcoin uses base 58. That's a mind-bending thing to do. Anyway, so we'll talk about this stuff later. Yeah.
These are what are used in amplification attacks.
Yes, that is the problem. These large records increase the power of amplification attacks, and that's why a lot of people were unhappy with this. And right now is the period when they complain about it the most, when these large records can be used in attacks, but they're not yet really doing anything to improve our security. So we've got the worst of both worlds right now in the early incomplete rollout of DNSSEC. And as you're going to see, DNSSEC solves a problem that hardly matters anyway. The real problem most of you have would be fixed by DNS Curve. Anyway, more about that later. So you can dig any. It used to work for City College and it probably still will. Any used to be the way to just tell me everything about this domain. Any is now deprecated. You are not supposed to use any anymore. What's that? Yes, it's considered to be a waste of your time. So you can tell how cool people are. Like if you dig any of ccsf.edu, it will tell you all this stuff and it doesn't even complain. But if you dig any about, say, ietf.org, let's see what they say. They also just tell you anything and don't complain, which is surprising. But I think if you do my, I think mine's going to not do it. Yep, mine tells you, nope, you can't use any anymore because I use Cloudflare and Cloudflare blocks it. So they send you an info record telling you stop using any, and here's the draft Internet Engineering Task Force statement saying we're not going to use any anymore, although the IETF is not obeying that rule. But I guess, anyway, so they won't tell you info, and on you go. Anyway, so any used to tell you everything. Now you're supposed to ask for them one by one for whatever you want to know. Because there really was no legitimate use for any. Whatever your service that's running is, it really only needs one answer. The only point you use any is because you're an evil hacker trying to steal all the data, and why should they serve you? Anyway, so the IETF, when it did answer any, would give you all the resource records too. These RR-SIGs are the signatures that verify that the other records are in fact intact and accurate. And if your client went through the mathematical verification process, it could be sure that those records really came from the right server. But since almost nobody has deployed DNSSEC, if there's an experimental version of Chrome where you can put on a DNSSEC enforcement, and almost all the internet is gone now. Only the very few sites that actually have the DNSSEC records will now show up. The others say, oh, this isn't signed, I don't trust it. You would be safe, yes. Just like if you turn it off, you'd be safe. You can't, you can't do anything bad with it anymore. Anyway,
It's safe in the sense that you'd be going to the right server.
yeah, it's safe. See, there's a difference between safety and security. You know, safety is just don't do anything that takes a risk. And security is when you actually do what you want to do and the risk is held down to an acceptable level. And that's why most of us continue to use the old insecure DNS, because we want to actually get to the website and do our job, and we accept the risk. But most people do not understand how big the risk is. The prime risk that normal people suffer is that everybody in your whole network around you knows everything you're doing, if they feel like running Wireshark or any other sniffer. And most people don't realize that. That is pretty rude. It's spraying the data about what you're doing to everybody around you. Your company IT department and the other people sitting next to you in the coffee house, and everybody can see everything you're doing, and that's kind of rude. Anyway, so what we've done these demos, here's the start of authority for ccsf.edu a couple of years ago. All right, anyway, if you want to do DNS queries and you're in some environment with a filed up DNS, like, by the way, Starbucks really messes with DNS. Weird things happen. City College is now messing with the DNS so much. So if you get tired of this, you use a DNS Looking Glass. And the Ring of Saturn is a good one. They're on my DNS page. So you can do your homework for, if you just want to do there's a homework where you do a bunch of digs to see this stuff work. And Saturn, all right. Looking Glass, perhaps? There. Nope. Looking. All right. I don't know why it's not on my page. I'm just going to Google for it. It should be on my page, but forget it. Ring of Saturn. DNS Looking Glass. I thought it was somewhere there, but if it isn't, I'll just do it this way. There it is, Ring of Saturn. Networking.ringofsaturn.com. There are a bunch of looking glasses on the web. So this is dig, but it's run from their server. So I can do the same stuff I was doing. I can do dig, NEIETF.org, and it will do it from their server and let me see it, and it's not dependent on my local DNS traffic. So I get all this jazz with all the RR-SIG records and everything else. And this is much more than 400 bytes, which is the limit of the original DNS. So this must be transferred using one of the extended protocols, either over TCP or with eDNS over UDP. And it's all handled up there, and I don't need to know. Very commonly, company firewalls will not let the modern alternatives through, so you can't get these signatures. Another reason why you can't really enforce them, frequently the signatures don't appear. And even if you get them, they aren't for every site. So right now, they're, from viewpoint of a client, they are just a useless waste of time. The servers talking to each other sometimes actually enforce them and get some benefit out of them. But anyway, that's the game. You can do digs from here, and you won't get such weird results. So the ones that I did earlier that was really pretty screwy was to understand City College. Let's try it from up here. It should make sense. So if I do SOA for ccsf.edu from off campus like this, I should not get a screwy answer. I should get the expected answer of ns3.ccsf.edu. Now that is not an authoritative answer. These are flags. Query, this recursive query was requested, recursive query desired, recursive query available. It's a recursive query, which means it did not find this information in its cache, or it didn't necessarily find it in its cache. It went and asked somebody else, and the answer is not authoritative. I'm seeing data that is the copy of data from somewhere else. If I want authoritative data, I have to go here. So I can take this query and I can put at there. And now I can ask a question. And now I should get authoritative answers. Now I've actually reached the authoritative server. Now I've been told me something which is authoritative, although as you can see, it is not signed. So I don't have any like cryptographic authority, but at least unless someone has spoofed the traffic, it came from the authoritative source. Anyway, that's what looking glasses are good for. And you can also do reverse DNS resolutions to look a domain name up from an IP address. And this is a way you can, if you get some traffic that you're suspicious about, like spam email, you can take the IP address that handed it to you and search to see if that really belongs to the company it claims to be sending you an email, because typically spam email is sent with a forged from address, because they really don't want all the bounced email and all the complaints to go back to them. They send it to somebody else they don't like. Anyway, and so this is done with pointer records for reverse DNS. So in order for our main address, 147.144.1.212, to be resolved at reverse lookup, we have to put in our DNS this record, 212.1.144.147.in address ARPA. And it's a really strange system. The IP address goes in the name of the record backwards, not in the data. It's very strange. And in IP version 6, this turns into a real mess, as we're going to see.
What's the reason behind the doing that?
I don't know. I think it's some kind of a plan to make it a little bit faster in the early days of the internet when networks were really slow, so the most important data is right at the front or something. But in the modern world, it just seems nuts. So to do a reverse record, you do a dig minus X, and let me give that a shot. Let's try that one. I've my looking glass up here, so I don't have to deal with weirdnesses of our local network. Let's try dig minus X for 147, 144, 1, 212. And that should find out who owns that. And the answer is, well, there's a bunch of answers. Cloud.ccs.edu. That's the official fully cloud-defined domain name of that server. And here's our ISP, and here's part of it. So we have a record that looks like this, saying we own that specific domain, and the entire thing, 147, 144, the whole /16 is controlled by CNIT, which is our ISP. So anyway, that's the reverse lookup, which people use for things like spam or any other kind of traffic where they wonder who really sent that. And this is also plain text and unauthenticated, so there's no reason to try to believe it with any high degree of confidence either. Anyway, I think we ought to take a break. It's been here for about an hour. Let's pick up at 7:10. Give you about 10 minutes to stretch your legs. Yeah.
How do you get this thing?
It is ringofsaturn.com. And if you Google DNS Looking Glasses, there are a lot of them.
So you have to pick any of those on the left side.
What's you have all these other things too. Yeah. It has many other things up there. One of the things you often see up here is BGP. But it looks like, I guess they're selling certification products or something. I'm not sure what all that stuff is. I just use the DNS Looking Glass. But there's a bunch of these out there. Mice and Men has another good one too from Germany. They also have DNS training classes. I went to some of them. There's a lot of companies that are like ISPs or big companies. They put up these looking glasses to help people diagnose network problems. And for a lot of things like BGP, you probably don't have access to it. So you need to go to somebody else's looking glass to see what's happening. And this is a good way to get out of whatever the problems are with your local network up to something that will see a plain generic situation. Anyway, I'm going to stop the recording for 10 minutes just to make it easier for people who want to view this later. I'll leave the share going, but I'll pause. Real AI. It's not just doing that. Anyway, so, all right, so let's carry on here. All right, so let's see. I guess that'll fade away eventually. Maybe I'm too impatient. Let me figure out how to get this thing off the screen. All right, and supposedly it will get off the screen at some point. All right, so great. So here's a forward lookup for Google. You dig quad A for Google and you get the IP version 6 address. There's reverse lookup. You can do a reverse lookup for the IPv6 address of Google, and you will get it. And look at what they had to do for IP version 6. They had to take the IP version 6 address and break it up into 32 pieces. This is the end of it is 200E, so now it's E.0.0.2. This is, and that's in the name of the record, not the data segment. It is very backwards and twisted, but that's the way it is. Yeah. Anyway, it does contain the information that you can get the domain name from that matches that address. It's just stored in a very weird backwards way.
Where in here would it say Google?
It doesn't. For some reason, Google's server is 1e100.net.
Oh, okay.
So I guess they're leasing time on somebody else's cloud to put it up, or that's their doing business as name or something like that.
So you would have to do a little bit more legwork if you're trying to say, like, confirm that an email came from here. It's not like
Yes.
to spit that answer out at you. You're going to go look up who owns those servers.
Well, apparently that's an issue, and so you wouldn't want your mail server to resolve to a goofy name like this, or it's not going to do the good of identifying it. And I think that's probably why we're having trouble with our mail. Because if the email server cannot understand the answer, they will figure you're an evil spammer. I didn't see what I expected here. And it is your obligation to figure out how to spit out what they expect, or you can't get the email through. Yes, yeah, it's pretty goofy looking. So anyway, so you have the root up there, you have the domains here, and here's the backwards records sorted by number. That's what it's like under the ARPA top level domain. It ended in .arpa to handle these reverse records. It's pretty screwy, but that's how it works. So a DNS Habit has got various things. It's got a header, and then it has a question, and then it might have an answer, authority, or additional records. So the query has just a question, and the reply will repeat back the question and have some of these answer fields if it was able to get an answer. And so it's not very big. And you see you've got a transaction ID, about which we're going to have much more to say later, 16 bits of supposedly random numbers. Then you have flags here like authoritative record and so on. Then you have number of questions, number of answers, number of authority records, number of additional records, followed by all that data. And that's what we've been seeing from DIG. DIG, being the old Unix tool, just shows you exactly what's in there the way it's laid out. Modern Microsoft tools try to format, other tools try to simplify it. All right, so there's the header. You got an opcode, and you have these various flags like AA for authoritative record, and RD is recursion desired, and RA is recursion available, and so on. These 1-bit bits tell it what's going on here. Now you got glue records, which is pretty messed up. Suppose you don't know where ccsf.edu is at all. So you ask somebody, where's www? It says, well, you better ask the authoritative domain, ns3.ccsf.edu. Where's that? Well, I can't find it until I can ask ns3.ccsf.edu. So if I don't know where ccsf.edu is, I can't ever find it. This is why the actual rules for DNS say you should always have 2 DNS servers, and one of them should be on somebody else's domain. That's the rule. However, almost nobody does that. Now, I believe City College actually does it, which is rather odd. We're one of the few people that does it right in this regard. If you do dig A, name resolvers for ccsf.edu, you will get, I used to get 2, but now I'm getting only 1. So this is a perfectly fine example of doing it wrong, although I'm on campus. The only resolver I get is at ccsf.edu. So if I didn't know where ccsf.edu is, I'm never going to find it. And if I do Yahoo, I think we'll find they've also done the same kind of thing, yahoo.com. Yep, all the resolvers are at yahoo.com. So this is a chicken and the egg problem. If you don't know where Yahoo is, the only way to find out is to ask Yahoo. Well, thanks a lot.
They would have to pay money to put their server somewhere else.
No, in the original plan, they would be not allowed to do this, but everybody did it. So they invented this thing called glue records, which are insane. At the top level domain level, they have to have a record for every domain. At the .com server, they have a glue record for Yahoo, tell you where the main resolver is, and City College and everybody else, millions of them. It is not cheap, and this is one of the things your domain registrar has to do. When you pay your fee to rent a domain name, they have to put a glue record at the top level, and it has to stay up there forever, as long as your domain name is resolved. So you can view them with DIG. So here,
They're being distributed around everywhere, so they can always be used by anyone when the internet went down.
yeah.
You always have to get back to that one server.
Well, you have to get to the top level domain, like .com, and that's, of course, a big cluster. But yes, if the top level .com went down, you would not have access to glue records. And if nobody at your campus had been to anywhere on that domain for like a day or two, it would not be in the cache, and you'd be hosed. You'd not be able to find companies. So if you look for the top level servers for EDU, you do it by digging NS for EDU, and then you'll get the EDU servers, which are pretty obvious. And now you can dig at that server, and you can get the NS domain at the root. This will give you the name servers. That's the second step here. And then you can get the IP version 4 glue for Google. So you go to nsservers.com, and then you do dig NS at that server, and you will get these glue records. A records for the name resolvers. So there are several records pointing to your name resolvers by hard-coded IP address at the top. And when I taught IP version 6 certification here years ago, there wasn't enough interest, so we got rid of the class, but it was rather interesting. If you set up IPv6 only networks, and you set up IPv6 only name servers and email servers and web servers, you have to register your domain through GoDaddy and nobody else, because they were the only American registrar that would actually put up an IPv6 glue record at the top level. Everybody else had not updated yet, and that meant you could not, in fact, be found only over pure IPv6. Certain steps could only be done over v4. And GoDaddy, although they're very politically incorrect, are very technically accurate to use the latest protocols and implement them completely. They were the only one I could find that would actually make IPv6 glue records. It was very interesting. There was a certification process, and if you bought your domain from the wrong company, you would get right up to the end and not win, because the last step required that glue record, and you have to start over again and buy a new domain from a different domain registrar, because you can't do anything to make that glue record go up. Only your domain registrar can. That's what you pay them for. And very few of them were, in fact, 100% V6 compatible. Anyway, so there's another goofy thing, the bind version query. You can query for a chaos record. And if you do, it'll tell you version.bind. Now, bind was the original DNS server on Unix, and everybody used bind. Bind was fast, but it had a lot of security problems. And for some reason, by default, it would tell you what version you're using, which is in fact a really bad idea because there are known attacks against each version. So this is considered a bad thing to have, and modern servers should not have it. So most version.bind records have been removed, but you can do chaos query, and some versions of bind will still do it. I was able to find it in 2015 at City College. We were using bind and advertising the version, but I doubt we're doing it anymore. Let's see if we're still doing text chaos. I know this local, if I do dig NS.
What was bind for?
Bind is the Unix server that does this DNS process, stores the records and hands them out to you. Just like SendMail is the typical email product people use. So this is the server, and now I just do dig at that server, version.bind text chaos. So let's dig at that server. Version.bind, a text record, and the domain is called chaos. The usual domain is IN for the internet, but this is called a chaos record, and we don't have one. I have a question, but I got no answer. That's the way it should be. I wonder if yeah, I'd have to do other servers here. I think it was ns1.google.com is Google's authoritative one. They're probably not going to fall for this. There probably aren't too many people still falling for this. Yeah, EDNS, yep, they also gave me no answers. Yep. So anyway, this is probably not too many people are still falling for that. There'd be people who haven't updated their DNS stuff in years. Yeah.
What kind of vulnerabilities does Bind have?
What's that?
What kind of vulnerabilities does Bind have?
Oh, you can take over the machine, buffer overflows, denial of service, especially in the early versions. It had all the usual problems because it's been around forever. Basically, anything more than 10 years old had all the really horrible phones in the early versions. And DNS is such a essential infrastructure tool that, like Cisco routers, a bunch of people set it up and never looked at it again for years. So it's just running some old version, not maintained, because your whole company depends on it, but you know, that means you don't think about it. And all the people that set it up have left, and the new people don't even know what to do. That's kind of what's going on at the college. We really don't know how to fix the DNS. That happens in a lot of companies. And then here's a bind version query in 2016 I did somewhere. This is City College again. And here they secured it. They changed it to secured instead of telling the bind version, which is a step up. And so here's the people who wrote bind. They still answer it. I guess they probably are proud of the fact that they're really running the latest version. It's supposedly not vulnerable, so they're not ashamed to tell you that. That might be the plan there. That's isc.org. I went down there and took a DNS class. It was pretty fun. Anyway. So you got your server architecture. If you're a small company, you typically outsource DNS to like Dime DNS, just like you outsource your web hosting. So you got your laptops and your client machines. You go through a router and a switch, probably not a hub. You go to your internet service provider, and your ISP has outbound DNS servers. So people trying to surf the web use your ISP's DNS resolver. And people trying to reach your company's server, you pay like Dime DNS to host your DNS server, and they're actually accessing cloud servers that are, again, not your problem. You do need two sets of DNS servers for everybody, every company. You have the outgoing servers, which permit your clients to surf the web, and you have your incoming servers, which permit your customers to find your resources. If you are a Microsoft shop, it is a natural thing to mix these two on the same server, and it turns out to be a very unwise thing to do, which we'll play with later. But Microsoft even, I don't know if they still make it, they used to make a product called Small Business Server to be cheap. And that thing was an email server, a domain controller, a DNS server, all in one box, which is a terrible thing. It's your single one-stop shop for all hacking, but it was cheaper than buying several different servers, which is the right way to do it. Yeah.
So on several dynamic DNS services, they offer like free IP addresses or domain names, right? How do they get around the $500 expense if they just have tons of different people in botnets using DNS?
Well, you know, they have to pay a fee, but they can update as many as you want. I know I've seen free domain names usually in like the .tk country code or something. What they do is they put malware and ads on the sites. That's what they, and you slow it down. You'll see all kinds of ads pop up and junk on your pages. You know, that's how they do it. They get the money another way. And maybe there's some way to get out of that $500 fee. I don't know, but that's what I've been told. I have not verified. Anyway, so in a medium company, you have internal and external servers under your control. You have your own DMZ, you have your own router. So what you ought to do here is you ought to have internal DNS servers like we do for the internal traffic, and you ought to have special ones in the DMZ for the external traffic out there. And those should not have records about the internal machines. They should only have the information about your public servers. So if people do manage to breach that DNS server, steal all the data, they don't find out anything really secret. All right, and your large companies, of course, have servers all over the place, and will use techniques we'll talk about like BGP, multi-homing and such, so that they multicast and anycast are the techniques used here. Anycast in particular is the way to really geographically distribute your traffic over the whole world, so it's almost impossible for anybody to bring you down. And that's,
Bring it down locally?
yes. And it's actually very difficult for that to happen. The point of Anycast, which is protecting the root of DNS and Cloudflare and many other large networks, is you put up servers all over the place and you give them all the same IP address. And then what happens is Border Gateway Protocol will send traffic to the nearest one. So if you're in Texas, you'll go to this one. If you're in New York, you'll go to that one, all to the same IP address. And if one of them goes down, it'll just find another one and go there. So it geographically distributes traffic over the whole world, and it means there's no way to attack one of them. If I try to send attack traffic to one IP address, it will smear out among them all.
Why wouldn't it send all the locals attack traffic to one of the centers?
It will send to the closest one until that one is busy,
Well,
and
that's
then
what
it
I'm
would
saying.
will automatically go to the next
It
one.
does sound like that would fall like dominoes.
It does, but in practice, that's not what happens.
Because aren't they also all serving the same thing?
Well, they are all serving the same thing, but you're right. It does, if it was a line and you could have your attack from just one point, it does sound like you could take them down dominoes. But in practice, I think that doesn't happen, because even if you're closest to one, the second one is 2 or 3 choices, and the third one is like 10 choices. So I think,
Put it out from there.
yeah, I think in practice, so people have tried this,
Okay.
and in practice, Anycast is extremely effective at blunting attacks. We'll get there, but I think we talked about it last time. There were DDoS attacks to take out the root, and they took out only the root servers that were not protected with Anycast. The ones protected with Anycast, they were never able to take them down. Anyway, so then you have hierarchical architecture here. You'll have a caching server here at the first layer, so the end users hosts get better service. Then you have more caching servers here and more caching servers up there. This is typically what you really have. You have a cache on your local machine in its temporary queue for a minute or two. You might have a cache in your router, cache at your ISP, cache at the server above that. So you're seeing a copy of a copy of a copy. But most of the time, you're getting fast service from something near you instead of having to wander around somewhere far away to get the information you need. And that's what I said. There's Anycast, where you have many servers with the same address, and people will just be automatically routed to the nearest one. And if one of them goes down, the traffic will just automatically route to the next one that's up across the whole globe. This is how you really keep things up if you're a large company with geographically dispersed servers.
Does the Anycast have to be configured from like an ISP type level?
Yes, you have to configure this in BGP, and it's difficult. So, but it's all done in Border Gateway Protocol, and there's only a small number of people who know Border Gateway Protocol. You have to get like advanced Cisco certifications beyond the CCNA, and I know Ed Horley's one of them. He's a guy that you'll see at Pacific IT Pros, and he is a consultant, and he flies around fixing people's BGP everywhere. You pay for some guy to fly in to fix it when it breaks, because your whole business relies on it, and it is really confusing. There's a small number of experts that zip around fixing everybody's BGP. Anyway, I'm just getting funny noises. All right, good. There's, I got another Kahoot. And then I'll just go to the lab and help people with projects. So let's, it's not listening to me again. Okay. All right.
Oh, yeah, again.
Yes. And this one. And I hope I resumed the recording. I did. Good. All right. Good. I forgot one time. So recording only had the first half of the class. That's why it's better when I can actually do it in the recording studio. The results are better. My home, it's smaller than this. It's across the campus. The problem is they don't have enough staff to staff it, so I can only do a couple classes a week there. But it makes much better videos. Yeah. It's actually broadcast on local TV too.
Well,
Yeah, it's all right. Anyway, it makes much better videos for students. These ones I make here are sort of home video quality, and they're somewhat better than nothing, but not as cool as what they actually get with a human doing the recording. That's a good one. All right, looks like we got most people. I'll wait a few more seconds. All right, they're still coming. UFO Didge, okay. Okay, 5 more seconds. All right. When you open Kahoot, what kind of query does your computer send? A recursive query, saying, I want the answer, and I don't care if you have to ask somebody else, just get me the answer. That's normally what you want. All right. What's inadder.arpa for? Those are recursive queries. I mean, the RDNS, reverse queries, not recursive, but reverse queries. It stands for reverse. And in is internet addresses. .arpa is the organizing body that does this, but they have the backwards records to find names from addresses. All right. So what DNS record stops spam? It's used to stop it. It helps prevent it. Like all security barriers, it is not perfect, but it does stop some of it. That is the Sender Protection Framework, SPF, as one of 2 or 3 systems used for this purpose. Where are the glue records? All right, they're in the top level domain servers. They're not in the root. That would be too crazy. At least they're spread around among the top level domains, which isn't really much better because almost everything is .com. What's that? Usually not. They're only there in case you need them. They're very rarely used. Yeah. All right. And so what DNS record contains an IPv4 address? Most common thing you want. All right, that's an A record for address. All right. And which record contains the name of a DNS server? That is the NS record. The C name is a canonical name, which is an alias, but the NS is the name of a name server. All right. So I'll record these winners as face again. I think it's probably the same face twice, I'm guessing. And M. Dot, I know who that is. And no LS also looks like a real name. So the only person missing is the face person. Are they in the room? Good. Okay, then I'll get the name. All right, then I think I'm going to stop the share and let this recording be recorded. Then I'll get that. No, people online can win too, but they do have to tell me the real name if they're going to use a goofy name. Let's end meeting.